Okay, so this is the next section in the notes. Something to point out, we're going to start talking about Riemann sums. We talked about this a little bit during class. So all a Riemann sum is just a bunch of sums of areas. So we use rectangles and trapezoids to approximate these Riemann sums. So what we're going to talk about now is what if we have all of these areas, k areas, where k equals 1, and we're going to go to as many areas as we need. The more areas we add up, the more accurate our answer will be. So given that, what if I wanted to make this be infinity? So if I wanted to have an infinite number of areas, so that would give me the most exact answer. The issue is that that's a whole lot of areas to take. But that idea of summing up a bunch of areas, an infinite number of areas, almost sounds a lot like a limit type of question. So basically, we're not actually going to do limits, but basically it'd be like saying, what is the limit as n approaches infinity of all of these areas? Which is right there. The limit is n approaches infinity of all of the areas. This is kind of where that delta x comes in, or dx as we saw in class. Delta x is just your change in x times, and this would be the height of the rectangle. So the height of the rectangle times your change in x. You're going to sum them all up as n goes to infinity. But really what that's going to change into is this integral symbol with a dx on the end. So all of that on the previous page, this symbol right here, not much to worry about, it's just the definition. This is what you are more interested in. So here's just some vocabulary for you. Let's do this. I am going to zoom this to fit like that. You should pause it right now and kind of copy these down before I talk about them. So do that quick, get them all copied down, and then I'll talk about each one. Okay, so welcome back. Your B term right here is called the upper limit of integration. That's where we stop integrating. A is your lower limit of integration. That's where we start integrating. We've seen those in class. This symbol right here is kind of like an elongated S. That's called your integral symbol. This whole thing is called an integral of f from a to b. And when you find the value of the integral, you have evaluated it. So you're going to see that a lot where it says evaluate the integral. And that's just where you actually figure out what it is given, where you start and where you end. The function is called the integrand. We talked about that in class. And x is the variable of integration. So there's that x right there. Okay? Remember that dx comes from that delta x that we saw before. So just a few quick examples. This one right here is barely even worth talking about. You'll never ever have to do this, but the limit is n goes to infinity. Again, it's summing up all of these areas where this is the height and that's your delta x. You could turn that into an integral that looks like this, and then you could take the integrand of it. To evaluate this integral, what I did was I graphed this. You could graph it on your graphing calculator. 4 minus x squared is a semicircle. It goes from -2 to 2. Because it is a semicircle, I am going to just find the area of a half circle, which is 1/2 pi r squared, with a radius of being 2, which gives me an area or an integral of 2 pi, and that is exact. That's not an estimate. An area under a curve is defined by a definite integral. Just looks like this right here. Remember I said if I ever say integral, you think area. Sorry if I'm going out of order. If f of x is less than or equal to 0, then the area is equal to the area above the x-axis minus the area below the x-axis. We'll get into notation stuff later, so don't worry about that next step, but just know subtract the two areas there. For these ones right here, to practice on your calculator, I do want to show you these, how to do them. So x sine x from -1 to 2. So I'm going to open up a new document, insert a calculator. Again, this is all under menu and then calculus, and there's an integral symbol. So this one went from -1 to 2. So menu, calculus, of x times sine x. Now, one quick thing, whenever you're working with trig functions or really anything, don't just do x sine x. You do have to do x times sine of x. Otherwise, it will not work. You will get an error message. So x times sine of x. And then we just click enter. Ooh, that's messy. If you go control enter, you'll get the area underneath that curve right there. Okay, one more just quick one so that you can see that one more time, and then hopefully you can try it on your own. 4 over 1 plus x squared. So I'm going to go to menu again, calculus, integral. Here I'm going to put the template key in. That was 4 over 1 plus x squared. And then that goes from 0 to 1. And my variable that I'm integrating with respect to is x. Click enter, that gives me pi. Wow, that's weird. Not really. If you think about the form of that, I believe it's one of the inverse trig functions, which we can explore a little bit more during class. So let's see here. So that's practice on the calculator. You can try the third one there. Constant functions, this one we've actually seen. Let's see here, a constant function, here's my graph. Here's a constant y equals x, y equals, let's say, a constant c. Not y equals x, y equals c. Let's say we're going to go over the bounds a to b. This looks a whole lot like that train question that we started with that first day. I just want to find the area beneath here, which means that if I want to find the integral from a to b of my function, which is a constant, so I'm going to call that c dx, that's actually just going to be equal to that constant times b minus a. And I'll explain that more further, but if you just look at that geometric approach there, that should kind of make sense. There's the train question. We already talked about that one. It's the same one as the one before. So you get 150, I think, if you go through it. This one right here, you could do this on the calculator, but really quick just to look at it, absolute value of x over x. It's a step function, not the step function, but a step function. Looks something like this, where it's going to be x over x, which is 1, but it's positive 1 when x is positive and negative 1 when it's negative. So negative 1 to 2. So basically we find this area right here. This is at 1 and this is at negative 1. And then we find this area right here, and we are going to add together the two areas. So this area right here would be 2 times 1, and that is an exact area. This area right here is going to be 1 times a negative 1, which means this area down here is equal to negative 1, and this area up here is equal to 2. So if I do 2 plus a negative 1, it means that integral is equal to 1. And again, you can check that on the calculator if you would like. And that is it. So there is one more video that follows, and that'll get us ready for class next time.